So let's talk about reaction rates. A reaction rate is basically how fast does the reaction take place. And in order for a reaction to take place, we have to have collisions between the reactants. And those collisions also have to have enough energy in order for the reactants to actually react with one another. So let's look at the things that affect a reaction rate. The first thing is the presence of a catalyst. A catalyst is any substance that speeds up the reaction but is not used up in the reaction. So remember, those are written above the arrow in a chemical equation. Also, it decreases the amount of energy required to make the reaction proceed, which makes it faster. So if we look at this chart, and it's called an activation energy chart or an activation energy graph, you can see the amount of energy that is required for the reaction to take place. So if we draw a line on the base energy and the activation energy, that's the top line, you can see that there's a difference between where it is and where it needs to be in order for the reaction to take place. If we change this graph and looked at one with a catalyst and then drew a line where its activation energy is, you can see that it's much, much lower. The baseline energy still stays the same, and if we got rid of the graph and drew vertical lines to actually see how much the difference is, you can see that the one with a catalyst is much, much less. So the presence of a catalyst increases the rate of reaction because it decreases the amount of energy required. The second thing that affects the reaction rate is the concentration of the reactants. So again, we're looking for collisions, and in this example, this picture, there aren't very many collisions that are going to happen. But when we add more reactants and we increase the concentration of the reactants, those collisions are going to happen with a lot more frequency. And when you have collisions that are happening with a lot more frequency, things are going to go faster. So increasing the concentration of the reactants also increases the rate of the reaction. The third thing that affects reaction rates is temperature. So here we have a little video where the molecules are moving and it's 50 degrees. And if we looked at a video where it's moving 70 degrees, you can see that they're moving a little bit faster. They have more energy. And now at 90 degrees, they're moving a lot faster. So again, increasing the temperature increases the energy with which these collisions are going to happen. And it also increases the frequency of these collisions. So increasing the temperature is going to increase the reaction rate. The fourth thing is surface area. So the surface area refers to the area that can react with one another. So if we took this big ball and we put it into a solution, the only thing that the liquid can do is react with the outside. Okay, so we've highlighted this in pink here. If we were to break that ball up, okay, break it up into a lot smaller particles, break it up and then put it into the liquid, you can see that there's a lot more surface area and a lot more area where the liquid can react. So again, it's highlighted there in pink. So when you increase the surface area, you increase the reaction rate. The fifth thing is just the nature of the reactants. So gases tend to react more quickly than liquids or solids. Reactions involving ionic compounds happen a little bit faster than covalent molecules. And larger, more complex compounds tend to react a little bit slower than smaller compounds. So just the way the reactants are formed and what kind of reactants there are and their state is going to make it happen faster or slower.
Created using Powtoon.